Welcome to the NICE Cognigy release webinar on the AI Ops Center. My name is Sebastian Glock. I'm Director of Product Marketing here at NICE Cognigy, and with me today is Benjamin Meyer, co-founder, VP, and Head of Architecture. In just a few minutes, he will give you a comprehensive tour and take you through the highlights of our brand new product, the AI Ops Center. As always, all participants are in listen-only mode, but you can use the chat to ask questions, and we'll get back to you in writing. Let's dive in with a big number, 1.2 billion. That is the amount of user inputs that were processed with Cognigy AI in 2024 alone. This year, that number is already a lot higher, and we're expecting it to go massively up in 2026. And this growth of AI isn't just with Cognigy. The overall adoption is, of course, exploding. Gartner predicts that AI agents will solve 80% of common customer service requests in the near future. So AI first is no longer the exception. It's the default of how customer service now operates. And as a consequence, AI has become mission-critical infrastructure. It is no longer a nice to have, and there are no more human fallbacks or workarounds. If the AI goes down, customer service goes down. And that can get customers, of course, into real trouble, and it's the worst case for any operations team. Now, what makes this challenging is that AI agents don't live in a vacuum, right? Every AI agent, even if it has 100% uptime itself, has dependencies with other systems and services. And that stack is getting more and more complex. So there are, for example, third-party APIs and backend systems that need to be available in order to complete transactions. Without high-performing STT and TTS services, there are no voice bots, and LLMs form the foundation of the AI agent's reasoning. So finally, when human agents are involved, the handover providers and contact center environments, they also need to work flawlessly in order to hand over a human caller to a human agent. Now, for all of these, Cognigy supports fallbacks and alternatives and tools to ensure continuity. But anyone who has worked with or in ops teams themselves knows the stories of failures, which were caused sometimes by trivial external troubles. So here's a couple of examples. Let's say an STT service runs out of credits. So as a consequence, voice bots just stop listening. So who gets that notification? Are there budget alerts configured in your STT provider? How do you even know what happened when a perfectly fine AI agent suddenly stops working? Or how would you instantly know that an external service is completely overloaded so AI agents can't reach the API anymore? In that situation, the AI agent will collect all the information from a customer to, for example, rebook a ticket, and then they will fail at the transaction because they can't reach the API. That is super frustrating for customers. They will have zero understanding for that. So how would you even know that this is happening if there is no dedicated monitoring and alerting for that specific API? And final example, and I believe this is based on a true story, how would you know that a colleague has updated the API key for an LLM, say on a Friday evening, to comply with security guidelines, but they sadly made a copy-paste error? Would your AI agent still work? And if not, how would you know what happened at that point of time? These were just a couple of examples of those hidden pitfalls. There are many, many more out there, and support teams have seen all of them. There's rate limits and IP blacklists and all sorts of external issues. And that is why today we're introducing the AI Ops Center. The AI Ops Center is a centralized dashboard for real-time AI agent operations at scale. It enables a new level of holistic observability, and its power isn't just limited to the scope of Cognigy AI. It extends way beyond it. With that, I would like to hand it over to Benny for a deep dive and a demo of AI Ops Center. Benny, stage is yours.
Thank you, Sebastian, for the introduction. It's a pleasure to now show the current state of the AI Ops Center. In the next couple of minutes, we'll do two things. First of all, I want to show where the AI Ops Center can be found in our Cognigy AI platform. We'll talk about important concepts like the health dashboard, alerts, metrics, and errors or defects. And then in the second part, I want to show real scenarios where the AI Ops Center shows the value that it brings and that it generates. because I will use the AI Ops Center to troubleshoot problems and solve them within my conversational AI project. Let's get started. So for this demonstration, I'm using one of our Cognigy AI environments, but everything that you see right now, this is a dev environment, everything that you see right now on my screen will be available to you guys very soon. So I've created a tenant for this demonstration called Webinar, and within that tenant, I have two conversational AI projects, one called Nexora and the other one called Airline Knowledge. So how do I visit the AI Ops Center? If I click on the user icon or the user menu, I can navigate into the admin center. And the Ops Center is a new section located in the admin center. As of right now, the Ops Center can either be visited if you are an administrator in an organization, or if you have the Ops Center user role assigned via the access control functionality. So let's go into the Ops Center now. As soon as I load the Ops Center, this is what I will see first. We call it the Health Overview Dashboard. The whole point of the Health Overview Dashboard is to give me an indicator whether something requires my attention. What I'll see here on the screen is the number of active alerts, and we'll come to alerts in a second. If the number says 0, nothing requires my attention. The number of errors that I have, that the AI Ops Center captured, errors that I should investigate. I see a graph of how many user inputs per minute is the platform in my organization, for my organization, currently processing. And I see the 4 main components, and a little bit of a background story for these components. The entire Cognigy AI platform, you can actually see it like a large pipeline. User messages arrive at our system, we parse these messages, they arrive via a channel, that could be Slack, Microsoft Teams, WhatsApp. So we parse these user messages, execute transformers, your input transformers if you have configured them. We do real-time translation. We then go through Cognigy NLU to do intent mapping and slot extraction. And then we run your flows. The flows are pretty freeform, as you know. So you could prompt an LLM. You could prompt LLMs multiple times. You can use one of our AI agents, the agentic ones. And you can connect basically to any third-party system out there via extensions or via HTTP requests, for instance. So we then execute these flows, create outputs, integrate or interact with third-party systems. And there's many things where something can go wrong. But ultimately, we'll create outputs and we'll send those outputs back to the customer. So the entire system forms a huge pipeline where messages come in, business processes happen, and then messages leave our system. So we thought, how can we visualize the health of this entire pipeline? And what we came up with is a concept where we divide this pipeline into 4 parts. Part number 1 is the voice gateway. In this demonstration, I'm not showing this part, but the whole idea is if something goes wrong with speech to text or text to speech because I lose connectivity or one of my zip trunks goes down, I obviously want to see it. Endpoints. And the Cognigy endpoint is a very important component because all user inputs and all bot outputs or AI agent outputs go through the endpoint. So we'll have quite some business logic in the endpoint. We'll do real-time translation as well as transformer execution. Flows, where we have the NLU model, flow execution, HTTP requests. We talk to large language models. We have AI agents, and ultimately we can do our knowledge AI search queries. And handover providers if messages leave Cognigy AI's system boundaries and if we hit Genesis Cloud, Salesforce, RingCentral, and other systems. So we have divided this entire message processing pipeline from user inputs via business logic to user outputs or AI agent outputs into these 4 parts: voice gateway, endpoints, flows, and handover providers. And in the context of the AI Ops Center, we call these 4 components. Each of these components, as you can see here in this list view, have subcomponents. And subcomponents can throw errors or defects, and they can use metrics to activate alerts. So what you can see right now, for instance, I have one active alert. So let's go and visit my overview of all active alerts and see how alerts actually work. I can go to alerts in two ways. Either, if I'm on the overview dashboard here, I just click on the alerts tab, and as you can see, there's also a small indicator showing me that something is active on this page. Or I can click on the active alerts tile and click on view all. So let's click on view all. So what you can see here is an alert just triggered called sudden message volume increase. So if I go back here, you'll actually see that I have quite a spiky behavior in this environment right now. And that is because I'm actually running a series of scripts in the background to load the system so that I can actually demonstrate the AI Ops Center. But the AI Ops Center has noticed, hey, there's something that you should maybe have a look at, because we are now suddenly processing more messages than what we have done beforehand. This is an alert that would help you, for instance, to detect if somebody sends you artificial load, maybe attacks your bot by just sending many requests into your web chat widget. Yeah? You would get this type of alert if the load that the system processes quickly changes by a factor of multiple. So let's stay with alerts for a second. What are alerts? An alert works by evaluating a metric and the value of a metric and comparing it to something. So let's have a look at metrics that we measure for the endpoint component. So here on this dashboard, as you can see, there's 4 different widgets. So we visualize the number of user inputs that we process per minute. We have a heat map that shows us the processing time end to end from when it arrives at the endpoint. Then we go through this pipeline, and when we are done with the flow execution, we, so to say, stop the clock. So we really see end-to-end latency. We also see that for transformer and other things. But basically what happens here is I have metrics. Customers can't add these metrics to our product because the metrics are something that our software developers add to our code base. And then the AI Ops Center collects these metrics every 30 seconds, stores them persistently in the Ops Center front end, or the user interface, retrieves those metrics from the AI Ops Center. And as soon as I have a metric, as soon as I, for instance, have the number of user inputs per minute that I process, I can actually start to define alerts and compare this value, user inputs per minute, with, for instance, a historic value. And this is exactly how alerts work. You compare a value of a metric with a hard-coded value. Let's say as soon as the number of user inputs per minute goes above 100, I could fire an alert. Alerts are something that our customers can also not define as of right now. The thresholds can also not be adjusted. So alerts, as of right now, we have a hard-coded list of alerts, and our customers can either activate or deactivate the alerts. And as I said, alerts compare a metric and its value with either a relative or absolute number. And this is how the system then understands should this alert fire, because this comparison is positive. In order to configure alerts, and as you can see, I have all of the alerts configured, you can be on any of these dashboards. Yeah? So the alerts are not dashboard specific, not component specific, and you can click on the alert section and click on manage alert. This modal will open, and here in the modal you have 2 tabs for alerts and for notifications. You can activate or deactivate alerts. Each alert has a description in order to clearly explain what the alert actually does and how it works. And you have a notification area. Within the notification area, you can tell the AI Ops Center what the platform should do if one of these alerts is firing. Right now, we have 2 notification methods. We can either send an outbound email to up to 5 different email addresses. And of course, you can work with email distribution lists. Imagine something like ops team at Cognigy.com or something like that, if you would put that in, everyone would get the email. Here, I just, for demonstration purposes, added my personal email address. And the second notification method, which is actually quite handy and quite powerful, is the webhook notification method. Here, the whole idea is if an alert fires, the Ops Center can call a webhook, and then you can use something like Microsoft Power Automate to receive this webhook call and then do something with it afterwards. Maybe you want to post a message to Slack or Microsoft Teams, or maybe you want to trigger a PagerDuty call to wake up somebody at night. All of this is possible because we support calling webhooks. The webhook, the way of how we integrate with webhooks is pretty simple. You have to specify a URL. You will receive an HTTP post request on that URL, and you can configure basic authentication. For now, I'll leave it at email. If you change the configuration of alerts and notifications, there's a little hint here at the bottom telling you that it might take up to 15 minutes for the change to become effective in production. So we talked about the health dashboard. We talked about metrics, and we have different sorts of metrics that we visualize on these dashboards in different graphs. Now let's get to the last point of this first part of the AI Ops Center demonstrations, the defects page or errors. What you will see is if I go back to overview and I click on errors, then I see a list of defects that the AI Ops Center has captured. By default, all of the defects that we capture will be compressed. So if we have a look at one of these defects, we have each error has a code, a unique code, and will provide documentation for those error codes on docs.cognigy.com. The error has a message describing what it is about, a count. So we are actually compressing and condensing errors. Imagine you would have a mistake in a code node, in a loop, and you would produce tens of thousands of errors per second. We don't want to list tens of thousands of objects on this page, but we would compress all of them, if possible, into one list item. Errors as alerts and metrics are depending on the component and the subcomponent. So here the subcomponent is actually knowledge AI query. So apparently we have some sort of a problem when querying Cognigy knowledge AI. An error has a timestamp on when we have seen it last time. So imagine you had a problem in a code node 5 days ago. 5 days ago it crashed the very first time, but the last crash just happened 5 seconds ago. So you would actually see this timestamp of 5 seconds ago. And you have additional information about which resource and in which project the error appeared. What you can also do is on this overview errors page, you can actually filter down by subcomponent. So if you're interested, you can, for instance, filter down and only display errors regarding your input transformer, for instance. Now, if I add this filter, obviously there is no error because there's no problem with my input transformers right now. What you also have is a drop-down that allows you to filter down by project. So imagine if you have all projects selected and this list is very long, you want to filter it down and maybe just select the Nexora project. And then you will actually see that in the Nexora project, there's no error right now because the error is actually in my airline knowledge project. If you unselect, you can select multiple projects or you can select all, which is the default. If you are visiting the detail dashboard or the details section of the endpoint component, for instance, you once again have the ability to see its metrics, its alerts or alerts considering this component, and you will also see the list of defects that are related to this component. So usually what I do, I start with the health overview dashboard. I'll have a look at all defects, and then I might actually drill in and have a look at the details. Great. So let's go and have a look at the first scenario that I have actually prepared, which is, imagine we build a flow and one of my colleagues configured a HTTP request node as part of this flow. Now imagine things happen. There is a spelling mistake in the URL of this HTTP request. So I want to send an HTTP GET request to my API server, but there's a spelling mistake in my API server's address. So if I now execute that flow and I execute that flow node, I will obviously have a problem, because as soon as I do that, I will have an HTTP request flow node that will actually fail, because when we try to connect to this API server, we cannot do a DNS lookup and the service just does not exist. So what I have now done in the background is I have started an additional script, and what this additional script does is it talks to a REST endpoint, and that REST endpoint executes a flow, and that flow contains this broken HTTP request flow node. I'll quickly also show you the project, just so you are aware of what I'm talking about. So here is my simple sample flow. I do an HTTP request node, sending a GET request to this sample API. And here at the end of my URL, the word should actually say random, but I only typed in rando, so I missed the M, which will of course lead to this HTTP request failing. So we can also quickly try it in the action panel. I say hi to this flow, and here you already get the details. Flow execution aborted due to failed HTTP request. Yeah, this is exactly what I just explained. So let's go back to the AI Ops Center and see how the AI Ops Center visualizes this problem and how I would actually understand that I even have this problem in production. So here on the health dashboard, you can now actually see that I have one active alert, one alert that is firing at the moment. It considers the flow component, yeah? And now we even have a second alert, but let's stick with this HTTP request one for a second. So considering the flow component, the subcomponent outbound HTTP requests has an issue. So as you can see, my mouse cursor is actually changing, so I can also click on it. And as soon as I click on it, we automatically navigate to the flows details section of the AI Ops Center, and we also navigate to the alert section. So now, as you can see, this alert called increased outbound HTTP call error rate is active. This tells me, okay, I'm trying to send an outbound HTTP request, but there's somehow a problem with that HTTP request. So I somehow need to fix outbound HTTP requests. Okay. What you can also see is that there's a new error that we have actually captured in the Ops Center. So let's quickly click here. And what you can see is, okay, so there is 207 errors during flow execution. One considering outbound HTTP calls and one considering flow node execution. This is a bit more generic. This is very specific, considering outbound HTTP calls. So let's click on one of these. This new modal now opens, and you will once again get a description or a summary of the error's code, the message, the project in which it happened, a flow with a human readable name, and the node with its name. And I can now click on this button, go to flow. So let's do that. And the project will now load, and it will show me exactly that HTTP request that I actually have to repair. So in this case, I know I need to fix the DNS name. So I'm copying the correct DNS name, fixing that, click on Save Node, and I have now successfully repaired this problem. I can also quickly check it. This is how you would do it as well. So I say hi. the flow is now the flow did now properly execute. I no longer have this issue, so we have repaired this defect, right? Imagine this would be a flow that is much more sophisticated, much more complex. So you would now actually fix the problem, do a test, maybe in the future run a simulation for talking to that flow in order to verify that everything is working. Now we can actually go back to the AI Ops Center. So as you can see, the outbound HTTP request is still in firing state because we have now just recently fixed it. So we'll need to give the AI Ops Center a little bit of time to capture that this metric measuring failures in HTTP requests, that this metric is back to normal. But we can now have a look at the second active alert in the endpoint component. So let's click on it. So an alert called sudden message volume increase fired. So if I go back to my overview where I see the number of user inputs that we process per minute, indeed, starting roughly 6 minutes ago, we somewhat doubled the number of user inputs that arrive in our system. Why did that happen? Well, pretty simple, because I in the background started a second script that would talk to the flow, that would send this broken HTTP request. And the AI Ops Center just recognized, oh, there was a change in how many user inputs arrive in our system, and triggered this alert. You can obviously also unsubscribe from this alert, but this alert was triggered in order to notify you, hey, maybe have a look, the load just heavily increased. Maybe that's something that you want to keep attention on. So I'll now stop this script in the background so that we only have our base load script, and we'll see in a couple of seconds that the load once again drops down to this reasonable level of around 40 user inputs per minute. And what we'll also see in a couple of moments is that the outbound HTTP request alert will resolve itself. So for alerts, you can't really do anything. You can solve the issues and solve the problems, but alerts, they either fire, or if you solve the problem, at some point they'll disappear automatically. Let's go back to the endpoint details and to errors. And no, sorry, it was in flow execution. So once you have repaired an error or a defect, you can actually mark this as resolved. So here we have a button, you can mark it as resolved. As soon as you would do that, we would delete those 277 occurrences of that problem so that the list once again shrinks. And if you mark all of them as resolved because you have repaired all of the problems that we have actually captured, then you will, of course, once again end up in an empty state like this one. As I said, the defects or the errors on this page, they will be stored for a limited amount of time, and you can see the time in our documentation later on. The whole point of this is if something crashed 60 days ago, then you don't want to investigate this event that happened 60 days ago, but you want to investigate the problems that happened just a couple of days ago, so they can really focus on solving the things that are most pressing. What you also see, apparently we really fixed something. The number is no longer increasing. Yeah? So we are no longer adding additional outbound HTTP request problems to our list. So if we now go back into the onto the overview, health overview dashboard, you will see both alerts are gone. Yeah, we have no active alerts. System load is back to this normal level. So we no longer have this alert active that says, hey, the message input is increasing. And we no longer have the alert for outbound HTTP requests that are breaking due to this incorrect URL. There is one last thing that I want to show, a third scenario, because right now we had a look at different alerts that fired. We had a look at errors or problems and how I could diagnose them. And I want to show one more thing. And for that, I have actually prepared an endpoint transformer. So here I have a REST endpoint with a bad transformer code. So what I'm doing here is I am using the crypto library of Node.js in order to generate some random character sequence. And what you can see is that there is actually a problem here, which is the API called random byte is actually not something that is available because it's actually called random bytes. So I have a transformer that has code that is actually not working. And what I'll do in the background, I'll start a second script that will execute this REST endpoint and that will run into this endpoint transformer in a loop just to create more issues that I can then investigate in the AI Ops Center. My script is already running, so I can actually go back in the Ops Center. And what you will see in a couple of seconds is that we'll have a new alert in the endpoint component for the transformer subcomponent. And if I go there and I click on errors, you already see the defect that we are producing. And we have already seen it 39 times, 46 times. So it's increasing because I will not stop my script. So I'm just hitting that endpoint in a loop now, 51, 56, increasing. And here once again, how would I actually diagnose this issue? And we'll also get an alert regarding that in a minute or so. I would actually click on the arrow. The modal opens. Now this time the modal looks a bit different and the button doesn't say go to flow, but the button says go to endpoint. So I can go there in a second and fix the problem. And what you can see, meanwhile, I'm now also getting an alert, increased transformer error rate. How does our health overview dashboard looks like? Of course, as I said earlier, the endpoint component has an issue. The transformers subcomponent has that problem, and either I click on active alerts or I click on transformers, and then I'll get there immediately. I know, okay, something is wrong with my transformers. The number of errors is heavily increasing. I have the details in here, and I can go to the endpoint. We'll obviously scroll all the way to where my transformer code is, and I can now actually solve this problem. Fix the API. It's called random bytes, not random byte. Click on save. Give the AI Ops Center a couple of seconds, and this alert will actually resolve itself. And if I actually go to the overview of my defects, I know that this number here, or I can see that this number is no longer increasing. Yeah, so we have 145, and earlier it increased every couple of seconds. So as you can see, the number stays the same. So we are not running into this problem any longer. And I can now, of course, also mark this error as resolved. And as you can see, the page keeps blank, so it's not coming back. And that's the indicator that everything is as it should. Yeah. And if I go back to overview, we still have the alert firing for transformers, but in a couple of seconds, this alert will also vanish, indicating that everything is all right and that my system is back into a healthy normal state. So that's it for the demo of the AI Ops Center. Let's do a little recap. We had a look at the AI Ops Center. We learned where and how I can actually access it. We had a look at the health overview dashboard with the number of active alerts, errors, and components and subcomponents that fire those alerts. We also had a look at the different areas of the AI Ops Center. Here, in this screenshot, the flows dashboard with metrics, alerts, and errors regarding this component. Those dashboards give you the ability, those areas give you the ability to drill down and understand where the problems are so that you can actually solve them. We also had a look at error tracing and resolution. We troubleshooted two different types of problems: the HTTP request with an incorrect URL and the endpoint transformer that had a type error, a JavaScript type error. All of these problems will be listed on the errors page. You can click on one of these errors and then troubleshoot the error. And the AI Ops Center will guide you directly to the resource, like a flow node, an endpoint, an LLM configuration that has a defect so that you can actually repair it. And we had a look at proactive alerting, how you activate, subscribe and unsubscribe to alerts, and how you can configure a notification policy with either emails or webhooks. So, but there's one more thing I want to actually show you and show the tech guys in the webinar right now on how it actually works behind the scenes. So everything starts with the Cognigy AI platform and our own software products. We have Cognigy NLU, Cognigy X apps, Voice Gateway, Live Agent, Insights, our entire product portfolio. The AI Ops Center builds on top of these products. And what it actually does is it captures metrics that we already expose from all of our software products. Then what we do is we brought in a system called Prometheus. Prometheus is a time series database, a database that is optimized for collecting metrics on a regular basis. For instance, every 30 seconds. We're collecting tens of thousands of metrics every 30 seconds. So it is a system that was perfect, that was built for that use case. Prometheus comes with a second component called Alert Manager that actually helps us to manage alerts, to fire alerts, and then to execute actions like sending outbound emails or calling webhooks. The AI Ops Center fetches the data from Prometheus and then renders visualization in the front end, as we'll see in a second. The Ops Center also talks to Kubernetes. Yeah? As most of you might know, we run all of the software products here in this drawing here at the bottom on top of Kubernetes. So the Ops Center talks to Kubernetes directly, and when you create alert definitions, or when you subscribe or unsubscribe from alerts, and when you create a notification policy, we actually talk to Kubernetes and we store alerts and notifications and their configuration within Kubernetes in the form of custom resources. Prometheus, an alert manager, reads those custom resources and then actually reacts. And then we also had a look at errors. So all of those software products, they can emit their defects in a specific format. They emit them to the Ops Center. The Ops Center compresses or compacts those errors and then actually stores them persistently, in that particular case, in MongoDB. And then last but not least, we saw the custom visualization layer that we actually built as part of the AI Ops Center. That's the health overview dashboard that plugs into the AI Ops Center, pulls the currently active alerts, as well as an overview of the errors, pulls metrics and updates individual charts on a regular basis. That's this custom visualization layer that we built. And this is how the AI Ops Center works behind the scenes. That's it from my side for today. Back to Sebastian.
Thank you so much, Benny. That was a truly great demo. Now let's zoom out a little bit and look at the impact of what the AI Ops Center delivers to our customers. First of all, it's all about ensuring business continuity. Our AI agents often work in mission-critical environments, and we aim to avoid any form of disruption and keep the customers happy by providing continuous services. Secondly, the goal is to proactively address issues before they have customer impact. And if that still happens, the AI Ops Center can significantly reduce the time to recovery and therefore minimize the amount of tickets that pile up during an incident. That is critical for operational efficiency. And finally, the AI Ops Center is a driver behind the overall project success. It helps build trust and confidence in AI, and it contributes to the ROI of AI investments, which ultimately makes it a driver for a wider AI adoption in the enterprise. So what's happening next? The AI Ops Center is available today with release 25.22 on all environments. So if you go to the Admin Center in Cognigy AI and then to Ops Center, you should see your own dashboard populated with your real-time data. Now, the advanced capabilities, such as drill-down analysis or error tracing, are subject to an additional licensing. They can be activated on your environment and do not require any extra implementation or changes in your current AI agent setup. To learn more about that, and if you like, activate the AI Ops Center on your environment, please contact your NICE Cognigy Customer Success Manager or just send us a message. With that, we're at the end of the webinar. Thank you very much for your attention and have a great rest of the day. Bye-bye.